We've studied the parts of a computer and about the CPU, the RAM, the hard drive, and peripheral devices that we can add on to that, expansion cards. Um, so now we're going to start using a Raspberry Pi. Now, a Raspberry Pi has all of that just in the size of basically a credit card. And so there's input-output devices like USB, there's a network device, it's got a built-in video card that outputs HDMI, um, and it has expansion slots. These are GPIO pins. They're very similar to sort of the expansion cards that you can add to a motherboard, but a little bit more flexible, and we'll start playing around with that. The Raspberry Pi is often compared to the Arduino, but they are fundamentally very, very different. The Arduino runs firmware, where the Raspberry Pi runs Linux. It can also run Windows. It runs an operating system where Arduino doesn't run an operating system, it runs firmware. And so let's talk about the difference real quickly. So when I say software, I'm really talking about an application that we'll develop. And a firmware is programming, so it is sort of a type of software. But I'm drawing a distinction here because the firmware sits right on top of hardware. It's in machine language oftentimes, and it communicates directly with the hardware. And so that's a much different relationship where an application sits on top of the operating system. It talks to Windows or it has to talk to Linux, and it communicates with the operating system, which then communicates with our hardware via this firmware. So the Arduino doesn't run any of that. And so some people say it's a little bit more reliable as a result because you turn it on and it doesn't try to boot up much of anything. It just executes the hard programmed commands. And updating it, you actually erase everything and put in new software. And so it has a new firmware and it just replaces it entirely. And so there's a much bigger difference here between software and firmware. We'll be using a GoPiGo from a company called Dexter Industries. Very cool stuff. And they will use the Raspberry Pi and it will sit on top of a microcontroller unit. The microcontroller unit is just like an Arduino, it runs firmware. So our software that we'll be developing, our application, will run on top of an operating system, and it will send the signals to the more primitive microcontroller unit, which is running firmware, and our software will communicate with the firmware here, and that will drive the motors that turn the wheels, and it will turn the servo that faces the distance sensor that's up in the front. And so all of that is this relationship between our software and the GoPiGo's firmware. This is GitHub. GitHub is a place where you can keep software repositories, sort of storage for software, but it's really sort of advanced because you can see version history. So you can go back and see every particular version, and this is really important. It's important so multiple people can work on the same project and their software isn't overwriting each other. And it's also really important because if we work on software, just like we were working with the turtle, if we imported the turtle library and then someone updates the turtle library and all the commands we were using to write, to go to, all of those commands that we were asking for the turtle, let's imagine someone changed all of those and now our app wouldn't work. It doesn't know what all those commands are if they changed them. So it's really important to understand what version of the modules, what version of your libraries, what they're currently at. And so you have to make sure that you're using the right version that matches your software. So that's an important thing, and GitHub plays an important role on that version control. Just a quick aside, Git is an open source software about how we use version control. It's what tracks changes and does a lot of really cool stuff. GitHub is a website that can store this for free for many people. You don't have to use GitHub if you're using Git. Just trying to clarify that a little bit. There are other sources like Bitbucket that can also use Git. Instead of uploading your code to the GitHub website after tracking changes, you can instead upload it to different repositories. So the way this is going to work is that I have developed a repository for the final. And so what you're going to do is you're going to fork this repository and sort of create your own branch of it. And what that means is that you will put all of your code inside this file, the student script. And so I've already set up some of the tricky stuff for you already. And what you'll see here is you'll be working on the class called GoPiGo. The GoPiGo, it sounds cute enough. But what this is doing is that it's saying, okay, take the file Pigo and take the Pigo class from that file and base this class on top of this one. So this your class will take everything that I have added to mine and then add to that. What that means is that if all of you guys are coming across a common problem and that you're really stuck on it, what I can do is I can go ahead and update my file. It won't erase your stuff, but it will give you new tools that you could use. So if everyone's having a hard time like turning 100 degrees, so turning your robot around and going the opposite direction, that's maybe a stupid example, but if that was a common problem, I could make a turn 180 method added to the class, and all of a sudden you could start calling it. And what this does is sets up a relationship that's very, very similar to how programmers deal with their code. I will list out here on this README, I will list out a lot of the functions that you can use, and I'll add to them. And so you can check back on this document and see what is available for you to use in your code, what helpful tools that I'm giving you. And that's very, very common because you're going to have a relationship. If you're building software, then you're building that on top of other software. And that's important for you to sort of appreciate that, the base layer can change and you need to keep up with what's happening at that base layer so that way you can use the new tools. And if I change a tool that was working in your app, and if I change it, it might ruin your app, and so that you would have to make those changes to keep up with how things are evolving on the base layer. Now we can connect our Raspberry Pis to a screen and see, we could attach a mouse and a keyboard to it and we could use it just like a computer. But we're going to make these headless, which means that they won't be connecting to a screen at all. If we want to remote control them and push our code to them, we will use SSH. So all of our Raspberry Pis have an IP address already. I set them up, and so we will, and they're all written on Post-it notes on every robot. So we will remote connect to them to their IP address, and then we will use a GitHub command to pull all of our code. It's not too hard. They give us this link here, and so we do a command called git pull and this address, or git clone, and it will copy all of this code and it will add a copy of that onto the software on our Raspberry Pi, and then we can just through SSH tell it to run our app, and you'll see our Raspberry Pi start to dance, and that will be the first task that you'll have inside your file, that there is going to be a dance method here, and our first project is going to be adding movement to this method, so that if this is activated, then it'll, your little piggy will make a fun little dance.